Hello and Assalamu alaikum. The topic for today's video lecture is how to determine inequalities for the given region. So there are two steps involved if you need to determine the inequalities for any given region. The first step is you need to find all the equations that bound your given region. And the second step is after you are done with the equations, you basically subdivide your equations into two categories, and from those categories then you determine the inequalities. So the process is defined. Your straight lines, they can be categorized in two ways. First, vertical lines, and second, non-vertical lines. Non-vertical means either horizontal lines or slopy lines. So for vertical lines, if your vertical lines, they're of the form x equals to some constant, like x equals to 2 or x equals to 3 or x equals to minus 1. So for vertical lines, if your region for which the inequalities are to be determined is to the left of the line, then what you do in the equation, you replace equal to sign by less than if your line is dotted or broken line, and you replace your line by less than equal to if your line is solid or unbroken line. So this is the point. And then if your region is to the right of the vertical line, then you replace equal to sign by greater than if your line is dotted or broken, or you replace it by greater than or equal to if your line is solid. So then for non-vertical lines, they are of two forms, either horizontal lines or slopy lines. So horizontal lines, for them, the equation is y equals to constant, and for slopy lines, the equation is y equals to mx plus c, where m stands for slope and c stands for the y-intercept. So here, again, there are basically 2 points. First point is if your region that you are trying to determine is above the line, then you replace equal to by less than if your line is dotted. And you replace your line by less than equal to if your line is solid or unbroken line. And the second point is if the region for which inequalities are to be determined is above the line, then you replace equal to sign by greater if your line is dotted or broken, or you replace the equal to sign by greater than equal to if your line is solid or unbroken. So these are basically two categories that you need to keep in your mind when you are trying to determine the inequalities for any bounded region. Now I'll explain the concept with the help of examples. So I've chosen two examples to explain the concept. So the first example, you can see the question. You need to write down three inequalities which define the unshaded region R. So if you look at the region, you can see that there are exactly three lines that bound this region. Three straight lines, 1, 2, and 3. So these are the three lines that bound your region R. So let us start and find the equations. Step 1, it was first find the equations of all the straight lines that bound your region. So let's say this line is line number 1, and this is line number 2, and this is line number 3. Let's start with line number 1. So for line 1, it is a vertical line, and I hope students you know that for vertical line your equation for the straight line is x equals to constant. So which constant? This is x equals to 2. Basically your line crosses x-axis at 2. So x-intercept is 2, so this is the equation x equals to 2. So this is the first equation. Now go for line number 2. Let's see what do we get from line number 2. This is a horizontal line, and I hope you know that equation for horizontal line is y equals to constant. And if you look at which constant, this is y-intercept, which will give us the equation. So y equals to 5 is the second equation, horizontal line, this one. For line number 3, if you look at line number 3, it is a slopy line. So for slopy line, the equation is y equals mx plus c. So you need to find m and c now to determine the equation. So let's start and find the value of m and c. So first, let's find the value of m. So for m is basically what? It is gradient or slope of your straight line. Gradient or slope of your straight line. So to find the gradient, you need 2 points on this straight line. So let's choose any 2 points. You can choose any 2 points on this line. You can choose even origin. You can choose this point or any other point. So let me choose 2 points, two exact points on the line. This point, let us choose this point. This is the coordinates. If you look, they are 8 and 4. So let me choose the point as 8, 4, and let me choose another point. Let's suppose I choose this point. You can choose any 2 points, whichever you want, exact points on the line. So both of these points, they lie on this slopey line, line number 3. You need to choose the points which lie on on line number 3. You can choose any point, like you can choose this point, which is 2, 1. You can choose 0, 0, or any 2 points. So I have chosen 2 points. My first point is 4, 2. X coordinate is 4 and y coordinate is 2. And my second point that I've chosen is 8 and 4. Now I hope you know, or all of you, you know that the formula for the gradient of straight line is m equals y2 minus y1 over x2 minus x1. So this in this first point, this is x1 and y1. X coordinate is x1, y coordinate is y1. They are just symbols, notations to represent the x coordinate of the first point and y coordinate of the first point. So for the second point, this is x coordinate of the second point and y coordinate of the second point, represented as x2 and y2. So now just replace the values and find your gradient. So your m is y2, which is 4, and y1, which is 2, over x2 minus x1, which is 8 minus 4. So if you simplify this, 4 minus 2 is 2 and 8 minus 4 is 4. So if you divide both by 2, so 2 1s are 2 and 2 2s are 4. So your gradient is 1 by 2. Now for the y-intercept, you need to just simply look at the graph. At your graph, just look where your line crosses y-axis. That is your y-intercept. So if you look at the graph, your line, it crosses your y-axis from the origin 0. So your value of c or your y-intercept is 0. So now replace m and c back in this equation, and you will get the equation of the straight line. So your equation number 3 will be, if you replace m and c here, so your equation, it becomes y equals, your gradient is 1 by 2 x plus your y-intercept is 0. So this means y equals half x. You need not write the 0 there. So you have got all 3 equations. Now you need to find the inequalities for them. You have got 3 equations. You just need to find the inequality. So let's do one by one. Now the first inequality, inequality number 1. So use this equation, x equals to 2. This is the vertical line. For vertical line, you need to look at the right. You need to look for the region. If your region is to the right, you replace your equal to sign by the greater than sign, right? If your line is broken, you can see, can you see on this? I hope you can see all 3 lines, they are solid or unbroken lines. So you will replace your equal to sign by greater than equal to or less than equal to. So this is your vertical line, x equals to 2. If you see your region R, your unshaded region is to the right side of this line. If you look at the line, your line divides this region into 2 parts, right and left. So if you look here at the graph, your R is to the right side of your line. This is basically your right side, and this is your left side of your line. So if you look at region R, it is to the right side of the line. You need to look for the region R, right? So region R is to the right of the line. So you will replace on the right side, your values, they are greater. So you replace your equal to sign by greater than. So your first inequality is your x is greater than or equal to 2, because your line is solid. If your line is broken, then you don't put this equal to sign. You just write x greater than 2. Now the second inequality. Y equals to 5. This is your horizontal line, right? If you look at the region, where does your region lie? Let me remove this. Okay, so now for the second line, this is y equals to 5, and your region, if you look at your region, it lies your this region R lies below the line. So in this case, you replace your equal to sign by less than sign. So in this case, your now y is less than or equal to 5. You need to look at R, where your R is. If your R is above the line, it's greater. If it is below the line, it's lesser. So why? Because this is horizontal line. For horizontal or slopey lines, you look whether your region is above the line or below the line. For vertical lines, you look whether your region is to the right or the left of the line. For the third and the last inequality, your equation is y equals to half x. This is your line. So where is your r? Is your r up or above the line, or is your r below the line? I hope you can see your r is above the line. So when your r lies above the line, you replace equal to sign by greater than equal to your solid line, and so these are the three inequalities. Now let us proceed to problem number 2. Problem number 2 is a bit more complex. You could see a lot of lines. There are 4 inequalities that define the region R. One of them is y is less than equal to x plus 1. Find the other 3 inequalities. So region R is bounded by 4 lines, and inequality for one of them is known. So first you need to determine which of the line is there for which this inequality is given. To do that, just convert this inequality sign into equation. So this becomes y equals x plus 1. Now look at the y-intercept of the line. It is 1. So which of your line passes y-axis from 1, crosses y-axis from 1? I hope you can see this is the line basically which intercepts, which cuts your y-axis at 1. So this is the line for which your inequality is given. So we need not find the equation or inequality for this line because it's already done. So I put a cross here. So this means region R, it has basically 4 boundaries. One of them is known. We need to find the other 3. So let's start, and I call this horizontal line as line number 1. I call this slopey line as line number 2. This another slopey line I call is at line number 3. And for line number 4, inequality is already known, so we just discard that because we already know that. So let's start first find the equation, step 1, and then we go for the inequalities. So for the equation, if you look at the equation of the horizontal line, we have discussed it earlier. For horizontal line equation is y equals to constant. So in this case, if you look, it's crossing your y-axis from 1.5 between 1 and 2. So let's let me remove that. So your equation in this case is now y equals 1.5. So this is the first equation. Now let's go for the second equation. It's a slopey line. Now you need to find the gradient and the y-intercept. So you need to choose 2 exact points on the line. If you look here, this is the first point, exact point on the line. All other points, they are not exactly defined. This is another point, and this is still another. So you can choose any 2 points from that. I'm choosing origin and this point, 2 and 1.5. So I'm choosing or we can choose this. Let's choose these 2 points. So so the equation is, y equals to mx plus c. So to find m, I have chosen 2 points. The first point is 0, 0, the origin, and the second point is this one on the line, which is 4, 3. 4, 3. So let's determine the value of m first, and m is y2 minus y1 over x2 minus x1. So in this case, this is your x1 and y1, and this is your x2, second point x coordinate, and second point y coordinate. So let's do that. Just replace the values 3 minus 0 over 4 minus 0. So your gradient m in this case is 3 by 4. So if you look at the graph, your y-intercept you can determine from the graph. Y-intercept is that point on y-axis from where your line crosses y-axis, and it's 0 origin. So your c in this case is 0. So the equation for the second line is y equals 3 by 4x plus 0. Or you can simply write y equals to 3 by 4x. For the third line, for line number 3, it's again a slopy line, and we need to choose 2 points again on this line. Let's choose which 2 points. Let's see which points we can use. Use any 2 points from this line. So let me use this point or this point. Let me use this point. The coordinates for this point, they are the coordinates, they are 3 and 0. And let me choose another point. Let me choose this point or any other point like this point. So you can choose any 2 points. So I choose this one and this one. So one of the point, its coordinates, they are x coordinate is 0 and y coordinate is 3, and for the second line x coordinate is 6 and y coordinate is 0. So your gradient in this case is again y2 minus y1 over x2 minus 6, and same formula. So let me simply replace the values. So 0 minus 3 over 6 minus 0, so that counts to minus 3 by 6, so that counts to minus 1 by 2. And if you look at the graph, your y-intercept, it's clearly 3. Your value of c, your line crosses y-axis at 3, so your value of c is 3. So the equation for line number 3 is y equals minus 1 by 2x, y equals mx plus c. I hope you can, from the graph, you can clearly see your line crosses y-axis from 3, this line, this line. So let's now find the inequality. Step 1 is done. All 3 equations, they are already known. All 3 equations, they are known. Let's find the inequality. For the first line, your region R, look at the horizontal line. Your region R lies, this R lies above this line, so your inequality will be y is greater than, and your line is unbroken, so greater than and equal to 1.5. This is your first inequality. Second inequality is, if you look at line number 2, this is y equals to 3 by 4x, this solid line, line number 2. Your region R, it again lies above the line. This part, this whole part lies above the line, and this is below the line. So you need to look where your R is. Your R is above this line. So again now, y, and this line is unbroken or solid line. So y is greater than equal to 3 by 4x. Now for the third and the last inequality. This is line number 3, marked as 3. If you look at your graph, your R lies now, where is your R? Is it above or below the line? I hope you can see this R. If you look at your R, this is below this line. This is below the line, not above the line. So and this line is broken line. So you don't put equal to sign now. You just put, since this is below, so less than, and this line is since this is unbroken line, so you don't put equal to here. Sorry, this is broken line, so you don't put equal to here. So y equals minus, y is less than minus half x plus 3. is your inequality. So this is the way you're going to solve the questions in which your region is bounded by some lines, and you need to find the inequalities to define your region. Thank you very much for watching the video.